morning. My name is Vittoria Grilli and I am at the end of my first year of PhD at Università Politecnica delle Marche. The main theme of my research focuses on cold recycled materials. In particular, the focus will be on the study of fatigue resistance and failure mechanisms. In this presentation, we will start with a brief introduction, then a literature review, objective of the research and methodology, methods, and as a conclusions, expected outcomes. Cold recycled material mixture are mixtures produced at environment temperature containing reclaimed asphalt, resulting from the demolition of end-of-life pavements. These characteristics make them eco-friendly materials thanks to the significant advantage both economic and environmental. There are different families of CRM mixture classified according to the dosage of cement and bitumen and consequently according to the bitumen-cement ratio. In this figure on the right, 4 families of CRM mixture are outlined. Each family is characterized by a distinctive mechanical behavior and failure mood. We have cement-treated materials that are stiff and brittle, in contrast with bitumen-stabilized materials that are stress-dependent. Then we have cold recycled asphalt mixture that are characterized by a high bitumen dosage, while cement-bitumen-treated materials benefit from the presence of both cementitious and bituminous bonds that can improve the permanent deformation resistance. Failure behavior of CRM mixture is a very complex aspect which still has not been sufficiently investigated due to the complex behavior resulting from the viscoelastic properties of emulsion and the elastic properties of cement, and due to a constant change in properties due to the cement hydration process. However, it is known that after a certain percentage of cement, there are different types of failure: shrinkage cracking, fatigue, and rutting. For example, cement-treated materials are fatigue-prone, while bitumen-stabilized material, typical failure mood, is permanent deformation. The mixture of our interest will be contain a percentage of cement between 1.5 and 2.5 and a percentage of fresh bitumen between 1.8 and 3%. So it follows that the prevailing failure mode is fatigue. Here is reported a case study regarding the Polish experience. In 1990, numerous transverse cracks appeared on the pavements. Field investigation led to say that the main reason of this extensive cracking was the overall high amount of Portland cement and the insufficient amount of bitumen emulsion. This led to the production of very stiff mixture which behaved similarly to the cement-treated materials, with the dominance of hydraulic bonds. This experience motivated the Polish road administration to develop the new requirements. It was decided to minimize the cement content between 1 and 2%, and where the higher cement content is acceptable, it is still necessary to design a mixture in such a way that the bituminous binding dominates over the hydraulic binding. Here is reported a case study regarding a field investigation of a trial section of Ayrton Senna Highway in São Paulo, Brazil. This study aims to evaluate the mechanical behavior of bitumen-stabilized materials in a base layer. Bitumen-stabilized materials behaves as a granular materials with height cohesion, showing stress-dependent behavior. This type of material is characterized by triaxial resilient modulus test and permanent deformation test. Since the main objective of this doctoral thesis is to contribute to the use of CBTM mixture in mechanistic-empirical design methods, the characterization of CBTM mixture failure behavior is necessary. Fatigue test will be carried out on both CBTM mixture and fine aggregate matrix. Fine aggregate matrix are the binding matrix of the mixture obtained by removing the coarse aggregate from the mixture. A multiscale approach will be used since CBTM is a particular composite materials where coarse aggregate particles, the inclusions, are dispersed in the fine aggregate matrix phase. Several studies have shown that the PAM properties affect the viscoelastic, fatigue, and fracture behavior of asphalt mixture. Also, they have fine aggregate matrix have the advantages of being more homogeneous than mixture, and then can improve the efficiency in laboratory testing. Will be carried out a complex modulus test for the stiffness characterization of a mixture. Here it is shown a previous study where the specimen were subjected to a diverse sign compression loading to obtain a fixed strain amplitude at various temperature and frequencies. As a result, a cold diagram and black diagram were obtained. In the same study, also fatigue tests were carried out. Specimens were subjected to an axial sinusoidal tensile stress at fixed temperature and frequency with the deformation level between 18 and 150 microstrain. As results, fatigue curves were obtained that showed the dynamic modulus as a function of number of cycles. At the end, we can say that the aim of the doctoral thesis will be focused mainly on three aspects. The first one is the investigation of failure behavior of CBTM mixture treated both with the traditional approach and with the viscoelastic continuous damage approach. Then the evaluation of the effect of two experimental variables such as temperature and voids on the fatigue behavior of CBTM mixture. At the end, the use of multiscale approach to carry out the fatigue test on FAM mortars and compare the results obtained with those obtained from the CBTM mixture. Thanks for the attention.